Thank you so much for inviting me to be part of your conference. I'm Brian. I'm a space engineer based in Houston. Myself and some other space engineers started this volunteer project called ISS Mimic. You'll hear more about it from Ms. Medina and Javier, some of the other educators that have already been partnered with us on this project. So the point of this is to bring the space station down to everyone. This model we created so that anyone can recreate it, particularly for you guys, for educators. We really want this to be something that helps you connect with your students, and then the International Space Station, which was really a global effort, can now reach out and be part of people all across the globe. So we're using 3D printed parts that you can make in your classrooms. We're using electronics like Raspberry Pi and Arduino to control motors, to control the model so that it matches the real space station in several ways in real time. In fact, the whole time I've been talking to you, our model has been synced up with the real space station, slowly moving its solar arrays to match the real space station in real time. So some feedback we've gotten from educators is, hey, this is pretty cool, but it's also a lot. There's a huge amount of components. It's a lot to assemble, a lot to print. It's expensive. So we came up, partnering with Ms. Medina and Javier and other teachers, feedback from there, we came up with this, which we call Mini Mimic. So it's the same thing. It's also running on a Raspberry Pi. It's also sending commands to an Arduino. In this case, it's commanding these smaller motors, these servo motors, so it turns the arrays not all the way, but most of the way. Can still sync up with the real space station in real time, but everything is scaled down. It's portable. It's simpler. It's less electronics, less cost, less time. Still a ton of 3D printed parts on both models. Even the solar arrays are 3D printed. Plus, there's vinyl cut stickers that you can put on there and really give them a nice look.
Hola amigos, estamos en vivo con Aya. Ella es una de las ingenieras que es parte del team de Mimic y nos va a explicar cómo funciona el ISS Mimic, la versión original. Y es lo mismo que van a estar ustedes viendo cuando nos traslademos a la versión pequeña, que es la que vamos a estar trabajando con los salones de clase y con los maestros. So Aya, can you tell me how this works? If I am in my classroom and I'm going to be connecting this to receive the telemetry from the station, where in the screen I need to go so I can see this moving according to same that is in the space.
Yeah, so like you mentioned, the telemetry is public information. It's posted online. So you're really going online, downloading a code that's already pulling that data stream. There's a lot more data than what you can really see on the physical model, so that's why we have so much on the data screens for you to kind of mess around with. If you want to see how the actual arrays turn, we can go in and control each individual one. So on this screen, you'd be able to select the array and move it based on whatever angle you want to change it to. So we would go in and set that to 0, start it, and then we can go back to our Mimic screen and go live. So right now we are live, we are transmitting, so I can hear the hum of the motors a little bit. They're trying to keep their position. And then some of the other things that you can look at, right, is a lot more with the control. As I said, there's so much public information, but you can't really see it on the physical model as much. So you can even go in and look at the orbit path so we can see where the space station is in its current orbit.
Can we see which astronauts are inside the station, on board the station right now?
Yes, we can. So if we go back and then we just go to crew, we can also see who's on board.
Okay.
We're just trying to pull as much of that public information as possible and do something with it.
So if we are having an EVA or a spacewalk, do we receive an alert or something?
Yeah, we do. So when an astronaut is leaving, there's going to be a change in pressure in the airlock so that they can go outside. So all of those are differences that we can see. So if we go into our EVA screen, we'll be able to tell, and if we go into the different airlocks, we can see that pressure difference. So
awesome.
All of this, like I said, is real time. There's one that's even my favorite to look at with our ECLSS, our life control systems, is the water recovery and management. So everything is being tracked on board the space station because we have to make sure that the people are surviving and thriving, right? So one of the things that we're tracking is how much water we have. And one of the places we get water from is the urine tanks on board. So you can actually see it update when an astronaut is using the bathroom on board in real time, and you can see that level increase.
Awesome. I didn't knew that.
Yeah, there's so much information that's out there, and the goal of all of these screens is really to just use as much of it as we can, have a place to kind of plug and play, and we're always looking for more input on more things that we can add and update them and make the graphics a little better and just include as much as we can so that you really understand that there's stuff going on inside the space station. It's not just this big thing that floats around.
So I know that we need to wait a long time for seeing Mimic doing what we want to see, which is the
Yes.
rotation in the solar arrays.
Mm-hmm.
But if our students are presenting this module or this one, which is the version for schools, and we want to show the public, the audience that is visiting us, the movement of the solar array, do you have any other modes that we can put this?
Yeah, we do. So we do recordings of the real data. So it's still actually seeing stuff that happened on the space station, but we can go to simulate orbits. So in this screen, we can play back at 60 times faster. That way we can actually see the motion of all the motors and the changing of the lights as things are happening. So if you want to go ahead and hit start on that HTV, we can watch some of that movement. So this is recorded data from when a vehicle was coming up to the space station, so you really see how those arrays move and try to move out of the way. This also highlights that those LEDs that we have are not just there for fun, although we do love LEDs, they have a purpose. So on here, they're telling us the charge status of the batteries. So as you can see, they're changing to red. That's telling us that our battery power is being depleted. So we're actively using battery, meaning that we're in the nighttime right now. And then we'll go blue to show that we're charging up the batteries, and white when they're fully charged.
Awesome. This is so cool, but listen, I wonder, what is this? Because it's disco, what is this?
Press it and find out.
Oh my God.
It's just another mode so that we can just show off the power of the LEDs, the motors, and how much we can move the model.
That's wonderful. Well, Aya, thank you so much for being with us and for being with all the lovely Mexican people virtually, and see you soon.
Yeah, thanks.